The solid is to be heated gently at first, then strongly, until no further change is observed. The effects of the heat and the appearance of the residue after heating is to be noted. All escaping gases are to be tested. Some hydrated salts will tend to dissolve in their water of crystallization, forming a saturated solution which, on further heating, produces water vapor, which sometimes condenses on the cooler part of the test tube and the solid reforms. The presence of the water could also mean the presence of a hydroxide, as they thermally decompose to produce water and the metal oxide. The evolution of iodine indicates the presence of an iodide. The evolution of bromine indicates the presence of a bromide. The evolution of ammonia indicates the presence of an ammonium salt. Oxygen by itself indicates the presence of a nitrate of a reactive metal, usually potassium and sodium. The nitrates of the group 1 elements thermally decompose to the metal nitrite and oxygen. Nitrogen dioxide accompanied by oxygen indicates the presence of a nitrate other than the metals of group 1. These nitrates of less reactive metals decompose to produce the metal oxide, nitrogen dioxide, and oxygen. The evolution of carbon dioxide indicates the presence of a carbonate other than sodium or potassium. These carbonates of less reactive metals thermally decompose to give the metal oxide and carbon dioxide. The evolution of sulfur dioxide indicates the presence of a sulfite. Metal sulfides thermally decompose to give the metal oxide and sulfur dioxide. A residue that is yellow when hot and white when cold indicates the presence of lead-2 oxide and could also indicate zinc ion. Blue or green solid given black residue could mean copper-2 ions, and pale yellow or green solid given brown residue could mean iron 3 or original iron 2 that was oxidized on heating to iron 3. A little dilute acid, usually hydrochloric acid, is added to the test substance, and if no reaction occurs in the cold, the mixture should be warmed gently. The evolution of carbon dioxide indicates the presence of a carbonate. The evolution of hydrogen indicates a metal above hydrogen in the reactivity series. The evolution of sulfur dioxide indicates the presence of a sulfite. A little concentrated acid, usually sulfuric acid, is added to the test solid or solution and warmed gently. The evolution of carbon dioxide indicates the presence of a carbonate. The evolution of hydrogen indicates a metal above hydrogen in the reactivity series. The evolution of sulfur dioxide indicates the presence of a sulfite. The evolution of hydrogen chloride indicates the presence of a chloride. The evolution of iodine indicates the presence of an iodide. The evolution of bromine indicates the presence of a bromide. The evolution of nitrogen dioxide indicates the presence of a nitrate. Carbonate. When heated, the solid decomposes and carbon dioxide is evolved. On addition of dilute hydrochloric or nitric acid, carbon dioxide and water are formed. Sulfates precipitate from solution as white barium sulfate on addition of a soluble barium salt, example, barium chloride. The precipitate is insoluble in dilute hydrochloric or nitric acid. Sulfide precipitates from solution as white barium sulfite on addition of soluble barium salt, example barium chloride. The precipitate reacts with dilute hydrochloric acid or nitric acid to produce sulfur dioxide. Nitrate. The solid decomposes with the evolution of nitrogen 4 oxide, and the solution turns blue on addition of concentrated sulfuric acid and copper turnings. Ammonia is given off after the addition of aqueous sodium hydroxide and aluminum powder. Chloride. It precipitates from solution as white silver chloride on addition of silver nitrate solution. The precipitate is insoluble in dilute nitric acid and sulfuric acid, but soluble in dilute ammonia solution. The solid also decomposes with the evolution of hydrogen chloride gas when treated with concentrated sulfuric acid and warmed. Bromide. This precipitates from solution as pale yellow cream silver bromide on addition of silver nitrate solution. The precipitate in dilute nitric acid and sulfuric acid is slightly soluble but readily soluble in concentrated ammonia solution. The solid decomposes with evolution of bromine when treated with concentrated sulfuric acid and is warmed. Iodide. This precipitates from solution as yellow silver iodide on addition of silver nitrate solution. The precipitate is insoluble in dilute nitric and sulfuric acid and almost insoluble in concentrated ammonia solution. The solid decomposes with evolution of iodine when treated with concentrated sulfuric acid and is warmed.